This video looks at some shortcuts for factoring quadratics. If you don't notice this, it's okay. It still works the normal way, but these are some shortcuts to help make you a little bit more efficient. So here we're going to expand first to look for some clues again. So first, outer, inner, last is going to give us x squared plus 5x minus 5x minus 25, which is going to give us x squared minus 25 when we simplify. Interesting. Let's look at another example. 3x times 3x gives us 9x squared plus 6x minus 6x minus 4. Simplifies again to two terms, 9x squared minus 4. Both are perfect squares. Finally, let's look at this one here. So here we've got 16x squared plus 20x minus 20x and then minus 25. This again is going to simplify to 16x squared minus 25. Binomial, where both terms are perfect squares. There's no middle term for each answer because the brackets have the same term but opposite signs. So the result is an answer that's described as a difference of squares. So here we're going to factor if possible. X squared minus 49. Both of those are perfect squares, so I can factor them as x minus 7 and x plus 7. Moving on to our next example, two terms. It is a difference of squares, so I've got x minus 10, x plus 10. Our next example is 64 minus a squared. Even though the a is second, this is still a difference of squares. I can factor this as 8 minus a, 8 plus a. My fourth example here for D is a bit of a trick question. X squared plus 36, not a difference of squares, so it's not factorable. To be a difference, it needs a subtraction sign. Our next set of examples get a little bit more complicated, where we've got a perfect square and a coefficient in front of the x squared. So here, we're going to take the square root of that first number with the x, and then we're going to take the square root of the second number, and then we're going to replicate the bracket, but switch the sign. Same thing here. Take the square root of the first number, take the square root of the second number, and then replicate the bracket, but switch the sign. Continuing on here, now we're getting a little bit more complicated with two variables. The approach is the same. We're going to take the square root of the first term, square root of the second term, and then we're going to replicate the bracket, but change the sign. Continuing here, square root, we can't do just yet, but what happens if I factor out a 3? If I factor out 3, then I have 9a squared minus 4b squared, and this bracket here does give me a difference of squares. So 3a minus 2b, and then replicate the bracket, but switch the sign. Finally, here I've got two terms, but now I've got an x cubed. What you need to notice here is that you can common factor, so I can take out 2x from both those terms, leaving me with 36x squared minus 1, which is a difference of squares, which then I can factor as 6x minus 1 times 6x plus 1. You should be able to recognize a difference of squares. It is always good to double check if your brackets at the end of a question can be factored further using this approach. The second special quadratic that we're going to look at is the perfect square trinomial. And let's look at some examples where we're expanding to look for some clues. So here I've got x minus 4 times x minus 4. This is going to expand into x squared minus 4x minus 4x plus 16. So here now I do have a middle term. Which happens to be twice the product of the terms of the binomial. And my last one, Now I've got 4x squared plus 6x plus 6x plus 9. And then simplifying that, I'm going to get 4x squared plus 12x and then plus 9. So my middle term is there. So b is equal to 2 times a times c. If you notice that, then you can factor the expression directly as a perfect square. If you don't notice, no big deal. You just have to factor as a tricky trinomial. So let's look at some examples here. Here we've got x squared plus 6x plus 9. What I'm going to notice is that my b term, which is 6 is equal to 2 times the square root of my first term times the square root of my second term. That means that it's a perfect square trinomial. So here I've got x plus 3 all squared. Now I'm going to take a look at my second one here. I'm going to look at my second term, b, which is 8. And I'm going to notice that 8 is equal to 2 times the square root of my first term times the square root of my last term, which means that I have a perfect square trinomial. So then I can factor as x plus 4 all squared. Moving on down here, I'm going to check my middle term, which is 12. And I'm going to see if 12 is equal to 2 times the square root of my first term times the square root of my last term. 2 times 3 is 6, times 2 is 12. So I do have a perfect square trinomial. So in order to do this, I'm going to take the square root of my first term, keep the same sign that is in front of the b, and then I'm going to take the square root of my second term, and then the bracket is squared. Let's take a look at another example here. I'm going to take a look at my middle term, which is 20, and I'm going to check and see if it's equal to 2 times the square root of my first term times the square root of my last term. It is, so I have a perfect square trinomial. I'm going to start off by taking the square root of my first term, keeping the sign that's in front of the b, and then taking the square root of my last term, and then adding the squared. Those are some examples of perfect square trinomials. If you don't see those right away, it's okay. You just need to factor as a tricky trinomial. And what I'm going to add up here is I'm going to say that a and c are your square roots of the coefficients, as we demonstrated down here in example 2.